I got a question in the Ask a Question section. A student was having some difficulty with one of the proportion questions and shared with me the two proportion questions that caused some difficulty. So this is a video response to those questions. So at first it says, in a normal distribution of test scores with the mean equal to 70 and a standard deviation equal to 12, what is the proportion of scores on the test will be greater than or equal to 66? And it says, the answer will be between 0 and 1 and should be reported to a thousandths place. And the answer was 3.71, and the student was curious, how do we get to that 3.71? All right, so let's go. All right, come on, pen. Sorry, a little bit more laid back here. All right, so here's what we've got. Our mean was equal to 70. Beautiful equal sign, isn't it? Okay, so mean is equal to 70. Standard deviation is 12. Oh man. And the score itself was equal to 66. All right. First step I always share with you is to draw the picture. So let's draw it. All right, and again we want to know what proportion of scores on the test will be greater than or equal to 66. So let's put in our 66 also. So we have three areas, A, B, and C. And we're interested in everything above 66, so B and C. Okay, the mean is right here, it's 70. So we know half the population is above the mean. Man, I just love this. Okay. So, half the population above the mean. Alright, and what we need to find out is the proportion of people between 66 and 70. Alright, so to get started, we're going to first need to figure out the z-score for 66 to find out how many standard deviations 66 is below the mean. So we'll say z is, z is equal to the value, which is 66, minus the mean, which is 70. Come on, I'll do. Over standard deviation of 12. Okay, that's going to be 4 over 12. That's a negative 4 over 12. And that is going to equal a negative 0.333. Okay, so negative 0.033. Alright, so, and this is for the area between the mean and z that we're talking about, between 66 and 70. That's what we need to find out so we can solve this problem. And we'll add it to the 0.50, and we'll have our answer. So to figure out this area between 66 and 70, we're going to go to the z table for area between the mean and z and look up this negative 0.333. Alright. Well, here we are, area beyond z, and that's not what we need. We want the area between the mean and z. So here we go. Area between the mean and z. And we want to know for 3.33. Now notice that there's no negative z-scores here. That's because the normal distribution is symmetrical. Z-scores are negative if they're below the mean, they're positive if they're above the mean. So the area between the mean and a negative 0.333 z-score is going to be the same area as between the mean and a positive 0.333 z-score. Okay, so we want, again, the area between the mean and z, and our z is negative 0.33. Here's a z of 0.3. We head over to this area, 0.03, and that is 0.019. All right. So come on, what was it? 0.129. So it's 0.129. 129. I gotta work this better. Forgive me, guys. All right. Well. Okay, so now we got to add up this 0.129 with this 0.500 to get the answer. And the answer comes out to be 0.629. Okay, so that lets us know the proportion of people who are have a score of 66 or greater. This person had typed in 0.371 and got the answer incorrect. Well, let's find out why. 0.371, my guess is what you did is you figured out A. That is, you went to the z table for area beyond z, and if you take this 0.33, negative 0.33, and you go to the table for area beyond z, you'll figure out A, but that's not going to help you solve the problem. You want to know 66 or greater. Now, what sometimes a different way of solving this problem is if you said this whole area is equal to 1, so 1, and you subtracted the area beyond z, which was the 0.371, you would end up with 0.629, which is the correct answer. In other words, if you take this whole area and you find out area A, you can subtract area A from 1 and get the area we care about. All right, I hope that was somewhat useful.